All right, so today what we're going to do is just take a look at how we can create a animated graph in a Teacher Desmos activity. So as you can see, we already have a bit of an introduction here, and just talking about the tangent line to a curve at a given point. So that point is A. So what we're actually going to do is on the next slide, we're actually going to create a graph that animates this tangent line. So I'm just going to quickly grab the equation for that tangent line. And all right, let's go. So taking a look at our graph. So we have a couple of options for the graph we want. So we could either use this first graph function here or the graphing calc in the full screen apps section. So obviously the full screen apps, those are full screen apps. We can't have anything else on the page. And the other thing to note about the graphing calculators is that the students are actually going to be able to edit any functions you don't hide and add things to the slide. So you may prefer to go with the graph if you're just looking for something that's a bit more like a picture and an animation. That's what we're going to do right now. So I'm going to grab that and drag that onto the screen. All right, so now you're going to have a graph. You can add a note if you want, or a text or math input, wherever you want. But for now, let's just focus on the graph. Click Edit Graph. And this is all going to, everything that goes into the animation is all going to happen on the screen here. So first things first, we're going to define a function. Let's just have some fun. Let's do cos x. And then what we're going to do is we're actually just going to paste that equation for a tangent that we had come up with earlier. Of course, you can have any sort of other equation. And what you're going to want to include is this term a. So that's a variable, right? That's going to be the point on our graph, the x value of the point where we're going to have our tangent drawn. This, of course, depending on your context, that could be something else entirely. But the important thing is that you use something other than x or y. So a value like a is great. You can use any letter you want. I think you can even use some Greek letters. So what you're going to see down here is it's going to ask you to add a slider. And if you click on that button, you're going to get a new slider. And all of a sudden, there we go. We've got a tangent line at a equals 1, so at the x equals 1 point. And if I change the slider by dragging it, you'll notice that it moves along the curve, and my tangent line is moving along with it. Now, if I want to animate this, all I have to do is just click this play button. And as you can see, it just moves along the curve, and then it moves back again. And in essence, that's basically it. If this is looking the way you want it, you just leave it playing, click Done, and then you'll notice that on your graph, your animation is playing. Now, I want to change a few things, and let's do that now. So click Edit Graph again, or maybe you haven't left at all. And let's change some things. So I'm just going to pause it so I don't have to worry about the giant flailing line. So first things first, I want to just focus on a smaller section, maybe just kind of more closer to just one period of the graph, maybe 1.5 periods. Now, we notice that we go between -10 and 10, so that's x values between +10 and -10. And if we have our number, at 10, well, we can't see that anymore on the line, and -10, we can't even see our tangent line. So what we're going to do is actually, if you notice down here, -10 and 10 are clickable. So if we click those or click anywhere else, it's going to give us this inequality here. And we can just set the upper and lower bounds for a. So see our lower bound is at -3. And our upper bound, why don't we set that at 8? Now, if you prefer, you can also go in here and type in something like -pi, so that's a bit more of an exact value. All right, and now when I click the play button, we'll see that it stays between this -pi and a +8, and then goes back and forth. Now the customization doesn't end here, so there's some other things we can do. If we go back in here, we have the option to set the step. So this is a spot where if you want something to move in, say, a discrete jump of 1 each time, so A goes to 1, then 2, then 3, then 4, without going through the intermediate values, you can set that step here. So for example, maybe we set it at 0.5, and if we click play, it's just going to move through those intermediate values. Notice the motion is a bit more jerky. I don't really like that, so I'm just going to leave the step blank and it'll do the default, which is a bit more continuous. Now we have some other options here. So you'll notice there's a little button here that says animation properties, and it's got a double set of arrows. We have a bunch of different options. So this first one here is the loop, and that loops forwards and backwards. So our A value will go all the way to 8 and then back to -pi. Now, if I want to say restart from the start when it gets to the end, I can use this button instead, which is the repeat in one direction button. So we'll click on that. And what you'll notice happens is as it gets to 8, it just goes right back to -pi. I've got a few more options after that. There's the play once button, and this will just play the animation one time, and then it stops at our final value. Finally, I have the play indefinitely button, and this is actually going to remove our inequality entirely, and it's just going to run through all these values and keep going. So this might make sense for something if you have it moving in a circular fashion, something where you have a bunch of coterminal arms or any other number of contexts. So I don't really want that. I'm going to go back to loop forward and backwards and set that range to -pi to 8. And there we go. So now that's going to play there. And the other nice thing about sliders is you can reuse that value of A for other things as well. Say I want to actually have the point where the tangent is crossing my graph of cosine. I can define that. So my x value is A, so we'll define that as a point. My x value is A, and my y value is f of A. And there we go. We can see we have that nice little point. If we long click on that, hold down for a second, you're going to get some customization options. So you can choose to show or not show the point. Now, you obviously want to show it. You can also turn on the label, and once you've turned that on, you have some options to actually change the label text over here. So you could say point. Not the most exciting title, but there's other options as well, of course. And finally, you have the drag option. So we're going to turn that off. And once we do, we're going to notice we get some additional customization options. We can do an open point, or we can do an X. So we'll do an X, and we'll make it purple for fun. And so that is the point where our tangent's meeting that. And you can keep using that for more and more applications, and depending on what you're trying to do, get a whole variety of different points. All right, let's take a look at what that looks like in the student view. So I'll click preview. And this is what our students would see on this page. Now, there's a whole bunch of things you can do with this other than what I've done. You can define multiple sliders. You can have a couple of different animations happening at the same time. There's pretty much infinite different things you can do with this. All right, and that is how you animate your graph in a Teacher Desmos activity. I hope you liked the video, and in some future videos, we'll be exploring how we can extend this even further with a computation layer. And of course, check out my website for even more videos on different Teacher Desmos features.